When you think about big tech innovation, your mind probably jumps to giant batteries, complex software, or maybe those super powerful motors. But sometimes the most game-changing breakthroughs are hiding in plain sight, inside the smallest, most overlooked parts. Today, we're cracking open one of those, a tiny pump that holds a very big and very valuable secret.
And it all starts with a question that sounds almost, well, too simple. What actually happens when an electric car just drives backward? The answer, it turns out, reveals a really tough engineering challenge. And in Tesla's case, it led to an incredibly elegant solution that, frankly, anyone interested in this space should be paying very close attention to.
All right, so let's get our bearings here. Just like any high-performance machine, an EV's drivetrain needs oil to stay cool and lubricated. What you're seeing is the basic system. You've got a pump, that's number 10, pulling oil from the sump, number 50, and it circulates it all through the heart of the car. The motor, gears, bearings, all housed in that box marked 40. This is literally the lifeblood keeping the whole thing running smoothly.
Okay, seems simple enough, right? But here's the catch. Here's where our simple question about driving in reverse completely throws a wrench in the works. See, this whole system is designed with one major assumption, that the pump is always spinning in the same direction.
See, the thing is, that pump is mechanically linked straight to the gear train. So when you drive forward, everything's great. The oil flows just like it's supposed to. But when you throw it in reverse, the gears spin backward, which means the pump, well, it spins backward too. And when a simple pump spins backward, it pumps backward. The entire flow of oil reverses, and that creates a situation that can lead to, you guessed it, catastrophic failure.
And trust me, this is a huge deal. We're talking about forcing all that gunk the filter just caught right back into your sensitive, high-precision gears. It can create a vacuum that messes with critical seals, and the end game here? Complete gearbox failure. The old-school fix for this is just to bolt on more parts. Complex check valves and other controls, which just adds cost, weight, and more things that can break down the line. So what was Tesla's answer to this mess? More sensors? Complicated electronics? Nope. They solved it with pure, simple geometry. The secret isn't some new gizmo. It's hidden in the shape of a part they already had.
So here it is. This is the pump we're talking about. It's a pretty standard design. It's called a gear torque pump. You've got the housing, that's 110, a cover, 112, and then inside the two bits that do all the work, an outer rotor, 130, and an inner rotor, 140. Looking at it like this, it seems totally normal. The real genius is completely invisible from the outside.
Okay, get ready because this is it. This is the secret sauce, the multi-million-dollar idea. It's the inside wall of the pump housing. This very specific, kind of weird-looking shape is the real hero of our story. It's what makes the whole thing so simple, so cheap, and so incredibly smart.
So the patent gives it a fancy name, the three-curve profile. But what does that actually mean? Well, instead of the inside being a perfect circle, it's this special track made of three parts. There's a curve for when you're going forward, that's 124, another one for reverse, 126, and then a little transition curve, 128, that connects the two. So how on earth does a simple shape do all this? Well, it acts like a completely automatic, purely mechanical switch. No sensors, no software, no electricity involved whatsoever.
The easiest way to wrap your head around this is to think of it like one of those track switching systems at a rail yard, but for oil. Depending on which way it's spinning, the pump literally switches itself onto a different track to make sure the oil always goes the right way. It basically thinks for itself.
And this diagram? It's perfect. It shows you exactly how this magic trick works. Okay, look at box 1, the pump spinning clockwise for forward motion, and that outer rotor, 430, is sitting perfectly in the forward curve. But the moment the car goes into reverse, the oil pressure itself physically pushes that rotor along the transition curve, 428. You can see it slide through boxes 2, 3, and 4 until, bam, it settles right into the reverse curve over in box 5. But here's the kicker, the part that's just wow. This entire mechanical switch, this physical part sliding from one side to the other, the whole thing happens in less than one single turn of the inner rotor. It's practically instantaneous. Okay, so let's put it all together and look at the result. On the left, figure 6A, we're spinning clockwise, going forward, and the outer rotor is sitting in its forward position. On the right, we're spinning the other way, counterclockwise, and the rotor has shifted over. But, and this is the whole point, look closely at those arrows, the ones marked 180. In both cases, even though the pump is spinning in opposite directions, the oil is flowing the exact same way, in through the bottom and out through the top. Problem solved.
And there's one last little bit of genius here. What keeps that outer rotor from just rattling around? Well, right at the top, where those two main curves meet, they form this tiny, sharp notch, number 122. That notch acts like a physical lock, holding the rotor securely in place. No springs, no clips, no extra parts needed, just the shape itself.
All right, the mechanics are cool, right? Super clever. But for anyone looking at this from a business or an investment perspective, this is where it gets really powerful. This is the genius of simplicity.
Folks, this is the money slide. This is why this tiny change is such a big deal. Because you design one smart part, you get to throw out a whole bunch of dumb ones. You eliminate the need for check valves and all those other controls. You stop the debris contamination and seal failures before they can even happen. It makes manufacturing and assembly way, way simpler. It lowers the cost for every single car that rolls off the line. And maybe most importantly, fewer parts means fewer things can break, which means a huge boost to long-term reliability. This is how you build a real, sustainable, competitive advantage.
And if you're wondering, okay, it's simpler, it's cheaper, but does it work as well? Well, here's your answer. This graph from the patent shows the flow rate. The circles are a standard one-way pump. The squares and triangles are the new pump going forward and backward. The performance? It's pretty much identical. You get all of those benefits. Cheaper, simpler, more reliable, with zero performance trade-off.
When you step back and look at it, what this patent really shows is a masterclass in engineering philosophy. It's a perfect example of incredible innovation hiding in plain sight.
You know, sometimes the engineers themselves say it best. This one line from the patent just nails it. The design decouples the oil flow direction from the direction of the gear train. It doesn't just treat the symptom by adding more parts, it re-engineers the system to eliminate the root cause of the problem altogether.
And really, this isn't just about a pump in a car, is it? This is a whole philosophy. It's about solving problems by going back to fundamental, first principles physics. Instead of slapping on a bandage, you redesign the system so the problem can't even exist. That is what true innovation looks like. So, at the end of the day, this is the kind of deep, clever engineering that creates real, lasting value in a serious competitive moat. And it leaves all of us with a pretty fascinating question to chew on. What other problems out there that we all think are already solved are just waiting for someone to come along with a simpler, more elegant, and just fundamentally better answer?